Hello, everyone, and thank you for joining us for today's Sense of Feely Sparring Partners webinar on simplifying 5G deployments with cluster connectors. This webinar is sponsored by CommScope. Our speakers today are Omar Parimbelli, Product Line Manager for HELIAX at CommScope, Sebastien Roy, Marketing Director for Radiall, Earl Lum, President of EJL Wireless Research, and Monica Paolini, Principal at Sense of Feely. I'm Kendra Chamberlain, and I'll be moderating the webinar today. In Sparring Partners webinars, we watch debaters discuss a topic and answer questions on video without slides. We would like to encourage our audience to participate in the discussion. Please use the Q&A button at the bottom of the Zoom screen to share your comments and questions. All comments are visible to all participants, so please keep the conversation polite and respectful. Our debaters will do their best to address questions as they go along and as they become relevant to the topics being discussed, so please do not hold your questions until the end. We've posted a few links in the chat of the Zoom screen. Those will link you to resources related to today's topic, so please check those out. And finally, we will be live tweeting today's webinar. You can follow along or participate in the discussion on Twitter using the hashtag Sparring Partners. With that, I'll hand it over to Monica.
Kendra, thanks so much for the introduction, and it's a pleasure to be here. This is the first session. We have two of them, so hopefully we'll get everybody on different time zones. And today's topic, I think it's interesting, and it's a little bit of a departure of the topics that we typically have on Sparring Partners, because oftentimes we talk about the sort of the high level, opportunities of different technologies. Today we're going to talk a little bit about, more about what enables those technologies, what actually makes it possible to, in this specific case, deploy 5G without losing your sanity because of the complexity of the technology. 5G is a great technology, and it's very powerful, but there is no free lunch. The improved performance of 5G comes with increased complexity. So to take advantage of the increased performance, you need to manage the complexity. And this is where cluster connectors come in, because they help us address it. So we'll talk about this, but before we do that, I would like to ask our debaters to introduce themselves, and then we'll start discussing. Keep in mind that you need to ask your questions as we go along, because we don't have a Q&A at the end. We'll just answer your questions as we go along. So Omar, do you want to start, introduce yourself? Tell us.
Sure. Thank you very much. Thank you very much, Monica. Hello, everybody. This is Omar Parimbelli with CommScope. I'm product line manager responsible for the HELIAX business unit in Europe and globally responsible for some project. So I'm an old guy in CommScope, more than 20 years with different business units, and now supporting HELIAX that is focused on coax connectors, coax cables, and fiber to the antenna and power to the antenna.
Great. Sebastien.
Hey, good morning, everyone. Good afternoon. I'm Sebastien Roy, located in France. I'm leading the product marketing for RF product with Radiall. Radiall is the leading company for connectors, designing and manufacturing connectors. Actually, I joined Radiall 3 years ago, looking for marketing and product marketing strategy for the RF product. So I'm pleased to be here and looking forward for a nice discussion.
Well, thank you, Sebastien. Earl.
Yes, thank you, Monica. My name is Earl Lum. I'm president of EJL Wireless Research. We are a market research company focused on antennas and radios and baseband units, and essentially anything that is bolted to a tower or a rooftop. So my background is in engineering as an RF engineer, as well as on amplifiers. But today, the topic obviously is about antennas and connectors and radios, and how to improve and the complexity or simplify the antenna line situation over at the tower. So I'm very happy to be on this discussion. Thank you.
Excellent. So why don't we start to talk about, why do we care about connectors? Why do they make our life or the life of the people that install 5G easier? And maybe Omar, you can get started on that, and then we'll open it up. But
yeah, that's a good point. So answer to the question why we take care about connector is actually a very, very important question. So we must definitely take care because connectors are the connection between different units. And in this case, we are talking about connection between the 5G new radios and 5G antennas, enhancing new bands, and so to deploy the new 5G. So connection and the connector is really everything, is the essence of the connection between these two things. So, I guess that in the industry, it's definitely clear to everybody how critical the connection and the connector is. So therefore, I think that talk about it is definitely extremely important. And from a company perspective and industry perspective, is definitely extremely important to pay a lot of attention to it, be very focused to have an excellent product and excellent quality. That's from a generic point of view, Monica, my view.
yeah, actually, there was a few weeks ago, there was a presentation from Rakuten, and Tarek Amin was, it was like a very high level presentation about their network. And he actually showed somebody putting up and mentioned connectors as being, one of the cost saving features. And so I think that that's really, those are the kind of things that it's easy to sort of like, you think about massive MIMO, beamforming, all this stuff, but how can you get it to work?
Definitely. That's extremely important because, the technology is changing. So when we think about passive antennas nowadays, we think about antennas with multiple frequency bands, okay, an antenna that are not any longer only 2T2R or 4T4R, but definitely 8T8R for the deployment of the 5G. So when it comes to 8T8R, of course, it's a kind of technical topic, this one, but we must be 100% sure that the antenna and the radio will work very well together. So this means that the beamforming that operators want to achieve, must be achieved. Otherwise, there's no sense to deploy such kind of technology. And when it comes to do that, is definitely not simple because we are talking about, for instance, about 8T8R to connect 8 plus 1 port from an antenna to a radio, okay? And the connection must be 1-to-1, and it must be a perfect connection. Otherwise, if we just, mix two of the connection between the radio and the antenna, I mean 2 ports, the beamforming will simply not work. And so we are going to lose completely the benefit of deploying an 8T8R radios and antennas. So what we thought about this issue is that we really need to propose something on the market that could fix it. So to allow a simple and easy connection to the antenna, just removing every issue in terms, so to be sure that the connection is reliable. That's the most important thing, that we are connecting the right jumper to the right port, because as I said, if we mix something, beamforming will not work. And then on the other hand, we also have to think a little bit about installers, okay? So we are asking installers to do something that is more and more difficult if compared with before, okay? And they have to do it right without really any problem. So must be very simple. And CommScope prepared and worked for a pretty long time on a new product that we call M-Lock, that is a very nice solution that fixed basically this problem.
Yeah, absolutely. So Sebastien, what is your view in terms of like the increased complexity, how the challenge that we're facing in terms of installing and the installation part? Or
No, of course, I have to to emphasize what Omar just said, it's very important to understand that the function is very critical. We always need to connect different systems, but moving forward, the technology is increasing. We need to do more and more generation after generation with the same function, and that all the difficulties and where the innovation come out to make this connection with more and more technologies, smaller, with more RF capabilities, with more RF performance overall. That could be in terms of intermodulation, could be in terms of power handling, or whatsoever type of what is necessary. The size also is also very, very important. So of course I subscribe to the difficulties and the necessary to have a very reliable connection between the system, or otherwise, I mean, all the benefits of the antenna, the radio, and so on will be useless. So the criticality, of course, of the connection is there, and it is true today, and it will remain true for many, many years in the future.
In fact, it's going to get more challenging because you get to higher order MIMO, you get, more sophisticated, you're going to have more complex sites. So if anything, things will get worse rather than, the challenges of the installation is going to get worse, right?
Oh, yes, yes. And this is where it comes all the innovation. We absolutely need to innovate in order to follow the trends of our customers. As a connector supplier and manufacturer, we definitely need to find new design, new interfaces, and so on in order to follow all the technology constraints. That's for sure.
Absolutely. Earl, I think that, you're an analyst, but you have a more hands-on, experience on this. Can you share with us what you...
Sure. So I've actually done some research on installing with the M-LOC system relative to using other cluster connector configurations that were available to see exactly, number one, how difficult is it to install? Secondly, how much time does it actually take to install it? And I can honestly say that I really don't want to see another roll of masking tape ever in my life if I don't have to with regards to installing, because taping up connectors and what the technicians and installers have to do is a difficult job, and knowing how to do it well and quickly becomes how one can differentiate themselves. It takes a very long time to tighten the connectors correctly. That's one of the nice things about the M-LOC is that it just snaps on and it's keyed. So one click and you're done with one hand. You don't need both hands to be able to install the connector. You could, and it's probably recommended that you do, depending on how long the jumper cables are. But again, you don't have to worry about having a torque wrench. A lot of these other tools that may or may not be available at the site, and certainly you don't have to worry about taping and weatherproofing the connector. And that is a major advantage to the M-LOC system that I've seen relative to any traditional connector that is out there, whether it's a push-on or a screw type, where you have to make sure that it is watertight and there is no ingress of any type of moisture into that connector that is going to degrade or cause the connector to fail.
So that's, so that there is one aspect that it's a good, you can establish a good connection and you can have it, good mating. But if you go beyond that, it seems like when you start having, higher order massive MIMO, you get to a situation where you need to have some sort of cluster connector type, because you just, at some point, you just cannot have too many.
Exactly.
So it gets to a point where it's not even an option.
Mm-hmm.
There's just so many connectors you can deal with. So
Yeah, if I can answer to your question, Monica, sorry to jump in. Also because I have seen an interesting question in
Okay, yeah, go ahead. Yeah.
Q&A, okay? And so definitely what you said is, everything is important. So dimension is important. The fact that must be something that easy to use is important. And let me try to show you something. Okay, that's just a demo of an antenna. Okay, just a demo of an antenna. But I guess it's great to show to the audience. Okay, the difference between standard connectors. Okay, and the new solutions. Okay, so what you see here is a 4310. I'm sure that everybody realize that's the 4310. Okay, well, you see in this antenna we have 2 ports this band, and then we have 8 ports for this band, and also here where we are using cluster connector, you see we also have 8 ports plus the calibration. But you definitely see how small it is if compared with the layout you need with the 4310. And there's an important thing that must be noted, also with the 4310, the clearance between the connector must be, when we design a new antenna, we always are forced to, consider some clearance here, because as Earl said, installers has to put the jumpers here on the single cable. They may want to use, a boot to protect it, or they want to tape it to protect it. So they need some space between one connector and the other, so to be in position to work. The new solution that we have developed is based on Next10. Okay, so Next10 connector is smaller and smaller, and if compared with 4310, and so that's giving definitely a great benefit in terms of space saving on the base station antennas panel. And this definitely allowed to have more and more connection on the antenna, and easier connection on the antenna. Okay, that's the point. In the question, I see the question is about, if we can use, if there's a cluster with smaller ports than 4310. So the answer is definitely yes. Why we went with Next10 is for many reasons. Okay, so using Next10, we can keep the cluster extremely small. This is only 30 millimeters, so 3 centimeters. Okay, it's definitely very small. So from a mechanical perspective, is very good. Then from an electrical perspective, PIM is important, return loss is important. And power handling is important as well. Okay, therefore we thought that Next10 is definitely a very good solution for that. Why? It's it's a kind of connector that ensures excellent PIM performance. So we choose this one, so to use the M-LOC cluster for both time domain and frequency domain application. Okay, basically our product is just one product you can use, so customers can use in frequency domain and time domain, because the PIM we guarantee is always best in class. Return loss, again, extremely important. We know how return loss of antenna ports could be critical. Okay, therefore the interface we use as mating with the antenna must be at its best, I would say. Again, Next10 was really giving very good performance. Last thing is power handling. Okay, so power handling is a very important thing. I see the question is about the 250 watts. Well, you know that always power is dependent on the frequency. Okay, but anyhow, we have also recently done, and the Next10 consortium has recently done updated RF power test on the Next10 connector. Sebastien is representative of the Next10 consortium team. So he can maybe provide better data to the audience. And we have, so we are going to have updated RF power specification for the next 10. And this will make this solution with Next 10 connector basically suitable for each and every application a customer may be thinking about, from very low band, so from 600 megahertz up to the new 5G TDD frequency without any problem. So.
Okay, so actually, so let's go through the first poll because it's kind of high level, and then we can address the questions. And I would like Sebastien also to talk a little bit about the standardization issues, because those are really important. So Kendra, could you go with the first poll?
Yes, our first poll. What are the main challenges in installing and increasing the number of antenna ports in today's deployments? Cable manageability limitations in space, training of installers, installation time, mating issues and reliability, or performance or PIM, passive intermodulation.
Okay, so actually, as we let people vote, do you guys want to take some of the questions?
Yeah. So not sure, maybe if we want to, there are all interesting questions, so I can maybe spend 2-3 hours talking about this one, Monica. Okay, all very good. I see that we have somebody in the audience, and thanks to everybody for asking questions. That's definitely great and very interesting, that are pointing to MQ cluster. Okay, so that's actually a very good point, because MQ is, we can call MQ as an RF cluster. MQ is not a CommScope design, of course, and it's a design that exists on the market since a long time. Okay, so I would say that years ago, starting to talk about clusters, you know, that was the only one really available on the market. Okay, what CommScope did was to, you know, start looking to what is available on the market, and of course try to do something that, you know, would exceed the performance of what is available already. You know, otherwise it would not make any sense to design a new cluster connector. So we started looking to what was available on the market. Yes, that's for sure. But then we end up with something completely different. And the major difference between our solution and other solutions available on the market has been listed shortly by Earl also before, you know. So you do not need a tool to fasten this one. A tool is definitely not needed. Oh, sorry for that. So you can just fasten with the fingers. I can show you now this one. Then you do not need any typing. That's the other interesting thing. So one is fastened to the antenna. It is IP68, so no need for any taping or cold shrinking or whatever it is. Then it comes with quarter-inch jumper and 3/8 jumpers. That's another important thing, because you know, everybody knows how attenuation between radio and antenna is important. Okay, so quarter-inch cables are good cables, nothing to say, but of course they are not really providing the best-in-class performance about attenuation. Therefore, M-Lock with Next 10 has been designed so to use also 3/8 low-loss cables that definitely provide better attenuation. That's another unique feature that you can really do not find on the market. Okay, so better attenuation, no tools for the assembly, super quick assembly, and and last but not least, of course, sorry, as I mentioned at the beginning, because it's designed with Next 10, it's really bringing excellent pin performance. So you can use this solution for FDD or TDD without any problem. So I guess that's the list.
Okay, let's go through the poll results.
Oh.
Kendra.
Okay, the results are, let's see, manageability and limitations in space received 42%. Installation time and meeting issues and reliability each received 21%. Performance and passive intermodulation received 11%. And training of installers received 5%.
Very good. Is that what you guys were expecting? I mean, I would imagine that, you know, I actually would have thought it would come out differently. I would just be worried more about training, installation times, and mating. But I don't know. What do you guys, is this what you were expecting? Sebastien, is that?
I'm not sure, actually. And actually, I'm looking for the result, but I don't see them, so it's difficult. Maybe I will pass this to Earl.
Okay, Earl, then that's you. You're on the spot.
Okay, this is pretty much what I expected from the top answer being cable manageability, especially if you think about the fact that if you look at the faceplate that Omar showed, it's already very, very busy with the 4310s and with the 9 next 10 cluster connectors there. And if you did all 4310s on that faceplate, you'd have close to probably 24 to 27 4310 connectors that you would have to individually tape, and assuming that you had the spacing in between each and every connector because you either wanted to weatherproof it with a boot or with some type of 3M tape or mastic as well. So given that fact, having to manage 27 jumper cables coming out of the faceplate of an antenna is a daunting task. And therefore, right now, we're not dealing with 6 or 8 port antennas like we used to. The addition of, and those were primarily FDD antennas. As we go now to a hybrid situation where we have both FDD and TDD, automatically with the beamforming, you're adding 9 ports to that faceplate. So things are going to get very crowded. And let's say you're going to do both 2.5 gigahertz as well as 3.5 gigahertz, and you were going to have 2 bands for TDD, both using beamforming. Now we have 18 ports just for the TDD without any FDD to even account for. And there's probably at least 12 ports of the FDD. So we're up to 30 ports now, and that is going to be a major problem for any installer. So I'm not surprised at all about the survey results being the top pick for cable management.
I guess that in a way, the sort of the cable management training and installation time all go together, because clearly it's not like one or the other. The more you have, the more complexity. So you need more time if you don't have a solution like that. So they're kind of all together.
I think the other thing you have to think about too is the hand size for the installers, and how are they going to be able to get that tape or that boot around from connector to connector becomes a major issue as well. And certainly in terms of the 9th connector port that would be on any type of beamforming, that calibration port is going to be marked specifically, so that way you're not accidentally connecting that calibration port to the wrong port on the radio. So there's also going to be a lot of complexity regarding each one of the 1 through 8 ports, as well as a 9th port, and how does that all jumper back down to whatever radio you're connecting to, because every one of the OEMs has a different way to label their connectors on their radios, and that just increases the complexity that we're just talking about.
Yeah. And then I guess you have different base station configurations depending on where you are, because you have more variability. So more density. So everything, I guess in all directions, you tend to have more of whichever dimension you go to. So clearly that adds on. Can you talk about the performance and PIM issues? How is that having a different type of connector help there?
Are you addressing this question to me, Monica, or
anybody that wants to take it up?
Well, I think if you look at anything related to TDD in the past, TDD is much more relaxed with regards to PIM performance. So you've been able to get away with a lot more on TDD connectors and antennas. In some cases, a lot of the TDD first generation antennas and even second or third generation were using N-type connectors because it didn't matter about the PIM performance. But if you start now having different types of connectors where you had specifically TDD connectors, then you had different ones for FDD, things are going to get very complicated, and it's going to make that much, it's going to make it that much more difficult for the installer to figure out which of these ports are the TDD ports at a particular frequency band, which of them are going to be the FDD ports, et cetera. So we're going to have a combination of both single port connectors like the 4310, as well as these clusters as we move forward because now we're combining both the FDD and the TDD arrays and under the same radome. And that's really the change that we're seeing now as we go to 5G. Before, we had a strictly FDD antenna, and it didn't matter about what the connectors were and so forth. But now that we're adding the TDD bands and the arrays in there, it's complicating everything. And I'll let Omar speak a little bit more about that.
Yeah, no, but you are definitely right. So while you were speaking just before, I was thinking to some customers, you know, when we were discussing about the reliability of the connection and the help of to use a cluster connector. You know, they realized by themselves that, you know, if installers are mistaken connecting, you know, port 1 to the wrong array, beamforming will not work. But if the installers will be wrong connecting an RF port to the calibration port, maybe something bad will happen to the antenna. So really to be very conscious about that and about the fact that the use of a cluster definitely helps, you know, keep the reliable the system because you're inputting only power where you are supposed to, okay, and that's definitely a benefit. And then on top of that, also bring the other benefit you have just described. So we have antenna crowded with more than 30 ports, okay? So the use of a cluster makes everything easier. And moreover, miniaturization of the connector is anyhow something extremely important because customers, of course, are not willing to have a larger and larger antenna, but the tendency is to make the antennas smaller and smaller with more and more frequency inside. So everything is getting more complex. So more things in less space. So we must look to something that miniaturize the thing. Another comment I would say is that move from a standard connector to a cluster connector is a mindset change. Okay, you're changing something important also in the way installers works. So my experience with customers is also that they want to start first with maybe one antenna, try it and see if it works. Then at the end, the results that I have seen is, that's a very good idea. So why don't we start using these also when we need for T4R, okay? Where actually we do not have exactly the same technical challenges with the 44R versus 88R. We all know that. But anyhow, if it's much more comfortable and at the end of the day, you always use the same jumpers, why not? And so we have now customers saying, buying a 28 ports antenna, previously only with 2 M-locks, now saying, guess we should review what we are doing. And maybe you should update your design so to, to have all cluster connectors. We are now designing an antenna with 8 cluster connectors for only cluster connectors, basically. Okay, wanted the 8 cluster connector, but because the customers see the benefit to do that. Okay, and I would like to try to show to the audience how the assembly works. Do you think, Monica, I can try it?
Absolutely, try.
Okay. So I'm going to move my camera, and I'm at home, guys. So okay. Hopefully you can still see the bottom of the antenna here. What's happened?
This is a real demo, not just.
Yeah, that's definitely. So what I'm trying to do is to assembly a 4-port M-lock. Okay, just to show you, there's an insertion key, okay, and then of course we have the 5 and the 4 ports version, so it's impossible to put this one in the wrong way, okay. And you know, the way you do it is, of course, I'm not on a pole now, I'm just using my desk, is just to fit this one in the antenna itself, okay, and then use this leverage to lock it down, and it's done, okay. So it's super simple. When customers try this one, they said, okay, what shall I do next? Nothing. Wow. Okay, so this is really working very well, and the feedback we have from the field is definitely very good. Then while you fasten with your hands only, then it's basically impossible to remove it only with hands. And of course, we did this on purpose, okay, because we do not want to make it easy to remove it, but just using a simple screwdriver that you know all the installers has, this can be then removed doing this. Okay, okay, it just take a little bit of strength to do that, but then it's super easy. Okay, really super easy. So I would say that also from operations perspective, it's kind of pretty good idea.
Now, we have a question that brings a whole set of different issues because, okay, it works good, but, you know, if you have different standards, is this an open standard? Or the question is the M-LOC connector a patented design for which other antenna manufacturers have to pay a royalty for it? So I guess that the question here is that no matter how good it is, if you can only use it in a very specific limited proprietary way, that you know the value is not as strong.
Yes.
And
yeah, you're right. You're
and maybe you can comment on the standardization efforts you're working on, the next stand work you're doing.
Yes, of course, because the M-LOC is based on the next 10 product, and of course this is part of the overall industry standard. We are with my colleagues and partners, Uber and Zuner and Rosenberger, we are all looking to standardize the next 10 products, and well, of course, there are a bit of royalties. I mean, we have to acknowledge the fact that some company innovates and spend some kind of money, you know, to innovate in terms of engineering and so on. So, you know, to be fully transparent, this innovation somehow is difficult to give it for free, you know, for the rest of the world. However, what is really important is that this innovation is accessible by anyone. And that's the purpose of the standardization, making sure that the all connectors manufacturer and antenna manufacturer can access to this innovation. And I think that the main objective of this exercise.
So
Omar, I think, sorry, I think the question also addressed the issue with the actual M-LOC system, and if that is under a royalty scheme as well, not just the next 10 connectors inside of it, but the actual patented design. Is that going to be available, or what is the situation with that from CommScope's perspective?
Thanks for the clear question, Earl. So we always have to think about the two parts of the connector, okay? So one part is also, as Monica said, the connectors that are on the base station antenna side, okay? So already now there are more than one, I would say, base station antennas manufacturers on top of CommScope that are already using it, okay? So we are definitely open to sell the connector solution to other base station manufacturers, and this is ongoing already. Then the something is to allow some other companies to use this by selling it. But the other thing that we are doing is, of course, to license the product to you know, well-known connector manufacturers. That's extremely important as well, because the product will never be successful on the market if we are the sole source. We don't want to do that, really. We think it's a good idea. We are licensing it to the best connector manufacturers actually in the world. One agreement, I guess, is going to be signed very soon. So, and of course, this will be made public as soon as this is done, because it's really important that everything will be multi-sourced. So not only the connectors on the antenna, but also the jumper itself. Okay. We are in the phase to do that, and hopefully we can, complete these agreements as soon as possible. Hope I answered to your question, Earl.
Yeah, and I think that this is quite important. There's also another question about whether the cluster connector is available prefabricated. And so I guess that your business model is you developed it, but you want to make it available to a large part of the market, because that's the value, is that you want to be based on, clearly protectable. You want to protect your IP, but at the same time, you need to make it available to the wide market. So you don't end up having everybody developing his own cluster connector.
No, definitely.
Otherwise, you have a nightmare of a different sort.
No, definitely not. Exactly. So the idea is definitely to give the option to more manufacturers to produce it, because that's the right way to do it. Definitely.
Yeah, absolutely.
That's the way. You're just pointing me to that question. Cluster connector only made available fabricated. If I understand correctly, the question is if it's available on terminated from both ends. Okay, so yes, in this moment it's available from terminated from both ends, and the reason is that in this way we can actually guarantee the perfect quality of the product. So and would not probably be a good idea only to sell this part with a blunt cut on the other side. That's not something we are doing right now. Of course, we are always open to change and to new ideas, but in this very moment, you can buy it with next 10 envelope on this side. That's always the same, 4 ports or 5 ports. And on the radio side, it's available, as Earl said before, OEMs are producing radio with every different connectors, okay? So in this moment, we have it available with N connector for the old type TDD radio. We have available with 4310, and we have also available with Next 10. That is now, we are starting to see the first radio with Next 10 as interface. So yeah, these are the flavors that are available right now.
Why don't we go with the next poll to talk about the 5G drivers? Kendra, do you want to go through that?
Yeah. Okay, our second poll, which 5G feature is the stronger driver for cluster connector adoption? Our options are multiple frequency bands, MIMO, or beamforming.
So yeah, I guess that's, and here in all our polls, you can only give one answer. So it doesn't mean that the other ones are not reasonable. You just need to, see what you think is the strongest driver for cluster connector adoptions. And I guess, we're talking about 5G, but what about 4G? Do you guys have any, do operators need cluster connectors for 4G as well?
Absolutely. I mean, I think the reason why it needs to have pin performance is because of the 4G for FDD that's out there, that is going to continue to be around for a decade or longer, depending on what everyone's time frame is for 5G. And there's still many regions around the world that are upgrading from 2x2 MIMO to 4x4. And then there's also the situation of the US leading the market with multiband radios, and how does that impact the actual antenna as well? And those are all FDD. So it's going to be very important to, again, from a PIM perspective, but also from the standpoint of the MIMO, in that we're increasing the MIMO order. And I know of at least one operator in Europe at this point that's deployed FDD 8x8. So we're looking at some very extreme examples now where everyone wrote off FDD 8x8 a couple of years ago in Barcelona as a interim step that the industry didn't want to go to from a radio perspective, yet we are seeing that now being deployed as of at least last year with one operator in Europe.
Yeah. So I guess it's a must-have with 5G, nice to have with 4G.
Especially if you're 4T4R in every band, and you do 7 bands, you have 28 connectors right there.
Exactly.
So it's going to be a disaster on that faceplate.
Yeah.
That's really the topic, you know. So the use of a cluster for 4T for our application is making the installation extremely simple. So again, as I said before, the customers that tried it for the TDD then start thinking, maybe it would be good to have, you know, also for the other.
Yeah, absolutely. And I guess that's where NGMN also is working on this, because clearly that's kind of an enabling base. And
GMN is now working on the cluster selection for the phase 3. Phase 3 is supposed to be the one that, you know, declares and find and rank the cluster connectors for both TDD and FDD. So the project is supposed to be completed by the NGMN team at the beginning of next year. So let's see. I guess MLOC is in a very good position, as at least as of today is really the only candidate that fulfills all the requirements for FDD and TDD. So
that's okay. Kendra, why don't we look at the results from the driver, from the poll, sorry.
Okay, yes, results are in. We have beamforming with 57%, multiple frequency bands received 26%, and MIMO received 17%.
Okay, what do you guys think? Is that what you were expecting again, or surprising?
Looks good to me. That's what I expected, at least from the beamforming side. Again, if we're looking at the fact that if you don't use massive MIMO of any order, whether it's 1632 or 64, then your fallback is obviously going to be AT8R with the beamforming. So in that situation, it is the simplest situation to deploy for 5G. It's the least cost impact if you're an operator to put up a passive antenna and the jumpers and a radio than to buy a 200 watt plus 6432 massive MIMO antenna system. And again, from power handling and power savings at this point, you may not need all of the beams that are coming out of that massive MIMO antenna if you don't know how many subscribers you're going to have on 5G on your network. So the easiest way to ease into 5G is to do the beamforming on the passive antenna, and then upgrade at some point to massive MIMO as the traffic increases.
Yeah. So actually, I saw that there was a question of NGMN, and we answered that, I think. But there's also another one that about power handling capacity and how cluster connectors compare to traditional connectors.
So yeah.
Is there a difference?
Wait a moment. I lost the question.
That's in the chat panel. So if power handling capacity, how close cluster connector with the traditional connector?
In terms of power handling, okay. So sorry, now I got it 100%. Well, you know, it's again frequency related, because power and frequencies are always related, as you know. But the reason why we as CommScope decided to go with the Next 10 is also because we are also antenna manufacturers, not only connector manufacturers or jumpers manufacturers. Okay, so we went out to this path exactly because we know which is the expectation from operators' perspective in terms of power handling. Therefore, the performance of the Next 10 that we can see right now with the updated spec are definitely comparable to a 2.2-5, definitely, okay? That, as you know, is not so far from a 4310. Therefore, I think that The next 10 we are using right now is really bringing us where we should be, okay, and giving us all the benefit in terms of dimension, because it's definitely smaller and smaller if compared with a 4310. So hope this answer to the question.
Okay, and then we also have two questions, which is about other manufacturers, and then another one about will there be an extended time delay from these third-party manufacturers to have access to the design? And I guess that is sort of like it goes to the sort of the topic we're discussing before in terms of, you know, does everybody has access, and the other side of it is like, do we risk to have fragmentation? And I guess if, you know, do you want to comment on this? Where is the market going?
Yeah, okay. So exactly the question is M-LOK connector a patented design for which other antennas manufacturer has to pay a royalty for it? So of course the royalty is something you have to pay if you want to produce the connector by yourself. But very often base station antenna manufacturers are not connector manufacturers. Therefore, they were going to buy it from CommScope or in a very near future from other connector manufacturers. Okay, so that's definitely the thing. You know, I guess this answers the question, Monica. Do you think so?
Yeah, well, I guess that, yeah, and Earl and Sebastien, do you want to comment on that as well?
I think the question was more, Omar, regarding the actual, you have the first tier of connector suppliers that are going to be signing agreements. So the question then becomes, if you're not part of that first tier, or if you're in the second or third tier of the connector industry, how much of a lag are you going to experience before you actually can sign an agreement, and or are they also in the same ability to sign as fast as everyone else is signing, or will there be always a preference to anyone that's certainly part of the consortium today as the first tranche?
Exactly, that's definitely the thing. You know, if you want to be an M-LOK manufacturer, you have to consider that you have two options: or you are in the next 10 consortium, therefore you can manufacture the next 10 connector by yourself, or you must be conscious that you have to source the next 10 connectors from the next 10 manufacturers approved by the consortium. That's the thing. So for all the guys that are in the next 10 consortium, is definitely easier because they only have to, you know, we only have to discuss about the M-LOK design itself. While if a company is not in the next 10 consortium, well, then there are two activities to be done. First, the next 10 consortium, and then the M-LOK one. So Sebastien, would you agree with me?
Oh, I fully subscribe what you said. We have the next 10 product, which is a patented product. We provided already a couple of licenses, and we know that soon to come, early 2021, the product will be accessible for in all the market. It will be an IEC standard product, basically, and this is the first step, I would say, to get access to the M-LOK, and then, because next 10 connector is a single port connector, right? And then which is integrated in the CommScope solution on the M-LOK.
Yeah, and I guess this answers the question of AISG as well, that is going to be included in the standard.
I think that's a little bit different, so maybe Omar can answer that.
Omar, then.
So yeah, definitely. You know, we always that's definitely extremely important, because as base station antenna manufacturers, you know, we know that on the market there we have some companies like CommScope following AISG 100%, but it's not really the same for all the antenna manufacturers. Okay, so for instance, if we talk about the mapping of the ports, we always think about cross-polar, because we want to follow the AISG, while there are manufacturers, important manufacturers, that are not really following these while going in that direction of the copolar. So we want really to follow AISG and work with the AISG and be in the AISG. Definitely no question about that. Then we also have to realize that there's a world where we live, okay, and where there are also manufacturers and customers that are maybe asking to deviate from that. You know, we would do that only if really needed. Otherwise, definitely, this is something that will be also, that is AISG related, and MLOC solution is designed according to AISG, to be honest.
And have they assigned, or what is the actual color code that you're using for the M-LOC, given that it's a cluster?
Oh, so we actually, that's part of something that has been agreed in the NGMN phase 2, to be honest, Earl. So we decided to continue to use the color on the antennas while defining the names of the ports that has to be silk print on the antenna and has to be reported on each and every jumper of the M-LOC itself, okay? So to be sure that looking to the antenna, everybody can immediately understand which band we are talking about and how is the position of the array, so just looking to the port. And the same thing on the cluster, so that once this is connected, okay, you can read on the bottom here, if this is, you know, this has to be connected on the, you know, center left port, or, you know, or right port of the radio. So that's the way we fixed it.
Okay, let's go with the final poll because when I had results to that, and since you know you've all seen how it works, let's see what you think the benefit from the cluster connectors are. So Kendra, to you.
Okay, our last poll. What is the biggest benefit from cluster connectors? Cost reduction, shorter installation time, error-proof installation, better performance, or no benefit?
So let me ask you, as we move to 6G, I'm gonna ask you that sort of a nasty question. So, but are we gonna see like, so now, you know, we're gonna have even a bigger number of connectors because, you know, we're gonna get more ports and more antenna ports. And so if you were to just, you know, just go on a limb and like, you know, 10 years from now, we're gonna have even further miniaturization, what we're gonna see? What's next?
I guess the first question is what frequency bands are we considering to be 6G?
Well, okay, I'm just like really kind of wide.
But also if you think about the fact that if you go massive MIMO, your connectors are going to shift from being external connectors to being board-to-board connectors. And I'm sure Sebastien would be very happy if he could sell a lot of these board-to-board connectors with the barrels. So more than likely, you're going to have just fiber plugging into a massive MIMO array of some type if we continue the trend of what 5G is today towards 6G. So in that essence, if you look at any active antenna unit today, there are no RF connectors on the external part of the radio. They're all embedded inside from board to board to board. And that's where we see the proliferation of connectors. They end up being internal connectors, whether they're SMP or some other type of standard that are going to be there, but you're not going to see an X10 or a 4310 or whatever new connector on the outside of it because everything's already integrated in with the radio.
Yeah, Sebastien.
Yeah, definitely. We are going to have a higher and higher volume of connectors, but we will see less and less connector, you know, from the outside. You know, that's the
right. They're going to be inside the box.
Yeah, because it's going to not be manageable. Yeah.
And yes, I will be very happy to sell more and more in-box connector, of course. And on our side, we will simply follow what is the market will ask us, you know, to design as new feature.
Hey, Kendra, we are
manufacturer.
about the hour, but let's go through the results here.
Okay. For biggest benefit from cluster connectors, we have shorter installation time, received 36% of the vote. Error-proof installation received 32%. Better performance received 27%. Cost reduction received 5%, and no benefit received 0%.
Well, that means there's a benefit.
Exactly. everybody has a way to voice their well, so I think that I think we went through most of the questions, but obviously we could be talking about this for quite some time and go into the more detail. But for those of you that want to know more, there is another session tomorrow, so it's going to be somewhat different. So feel free to join in that one or listen to this offline. And I would like to thank all the speakers. And Kendra, back to you.
Okay, thank you, Monica. Thank you, everyone. That will conclude our webinar today. Thank you to CommScope for sponsoring today's webinar, and thank you to our speakers for that great conversation. This webinar will be available on demand and as a podcast in the coming days. That will be available at senseofhealy.com. And we will also send out links to all of the registrants to access those. And as Monica mentioned, we have a second session coming up later today for me at 11 a.m. Eastern. And we have more sparring partners on Wi-Fi 6 and Wi-Fi 6E in October. The registration for that will be available at senseofhealy.com in the coming weeks. Thanks again, and we'll see you at future events.